Hello everyone. Today I'm gonna show you a neat reinforced concrete calculation tool. So if you go to costructure.com, the link is in the description. So you'll see these three options currently. So right now it only deals with concrete beams, but there's going to be further updates as well. So we can go through the navigation. So we just have these three: rectangular section, T-beam, custom. It's just basically the same as these three, and about section we can go to about later on. But if you click on the rectangular section, it shows up like this. So this is a desktop version. You can even try it on mobile, and it's responsive. It fully works there, so no worries. And this shows the cross section of your reinforced concrete beam, and this shows the strain diagram. This means like the neutral axis in here, and concrete strain is always like 0.003, so this is like 10 to the minus 3 scale, right? So that's why it's showing us 3 in here. And this is the neutral axis, and this is like the maximum steel strain showing up right here, and this is the edge, bottom of the concrete, right? So we can adjust our concrete. So this is like the geometry or the input, concrete, steel, and material. You can adjust everything in here. So in width, you can even click here like that, and then it will update the drawing, and you can play around with it and maybe make it like 20, and this is maybe like 28 or something, and then the graphs will just update accordingly. But as you notice, the right one doesn't get updated because it needs the calculation, and then it will determine the neutral axis, this one, and that. This will stay the same mostly, but after you click calculate, this will get updated. But for the left part, this will get updated whenever you change the input. So that's the concrete section. So the steel, you can have multiple layers of steel. So this one just has one, right? So you can choose how many layers of steel you have. So this one is just maximum of 10. So I'm just going to choose two. Let me just put these steels just a little bit below. So I can just increase the depth, and I can increase the second layer's depth. But as you can see, there's nothing showing up, right? Because you haven't increased the count yet. So now if I can put 4 steels, that's showing up, and then I can increase the count in here, and then it's just accordingly 6 counts on the bottom, 4 counts at the top. And these steels are drawn so that it has a cover of 3 inches. So the width of this concrete is 20, right? So this is like -7, and which means it has a cover of 3 inches from the left and from the right. So that is always constant. But I might make adjustments later on that we can, customize the cover length as well. So that's that. And in here, the total is representing the total area of these steel, right? But if you want to make some, custom, areas, like, 100 or 10 or something like that, then these left one doesn't get updated because the calculation only cares about the right ones. But if you change the count, it just automatically gets adjusted. So just be careful about that. And this second column is obviously the bar numbers, right? So I have one from 18, and 18 is like the highest, and 9 is like the most. You can say it's common because it has like 1 inch squared area, right? So that's that, and then you can increase the layer, decrease the layer, like that. So let's just put it as 2. And then the material. So material is pretty self-explanatory, and this is like the compression strength in KSI. You can increase that, decrease that, wherever, and this is should be always positive, so that's made it that way. And the maximum compressive strain of concrete is, I should have said in concrete, but EC, but this should also be lowercase, I guess. It should always be like 0.003 unless you know what you're doing, right? So just leave it at that. And then steel strength most likely be 60, and steel elastic modulus most likely going to be 29,000 KSI. So that's that. And after you set up all the inputs, you can just click calculate, and then it'll just take a second to calculate, and then there's your results. And this strain diagram gets updated accordingly. And to take a look at the results. The result is in kip inches. This is the factored one, and then this is the unfactored. And the phi factor is in right here, and the neutral axis, as you can see, it's like 4.3 in here. And the errors, I'll talk about that in a second, but the max steel strain, this is the most bottom steel strain, right? So if this is like greater than 0.005, then you're good. But I think the code says it has to be greater than 0.0045, I think. So, but I mean, I just think of it as like if it's greater than 0.005, then it's good. Let's talk about the error of forces. So, as you can see, the neutral axis is in terms of 3 decimal precision. So I could have gone further, like I could have had like 10 the decimal precision, right? So if I had more precision, then the error would be less. So what does the error mean? So error means I'm basically choosing this neutral axis in this spot, and then I'm calculating all the tensions and all the compressions on either side, like on the up section, the bottom section. So in here, I would have the concrete tension, the steel tension, and the concrete compression, the steel compression, but on the bottom I would have the steel tension, right? So these two forces has to be exactly the same. So that's why it has like a kip unit, because it's force, right? And so if you add up all the tension on the top and on the compression on the bottom, then you would have like 0.005 or 0.0545 kips of error. So that's what this error means. It's just basically the sum of tension plus sum of compression, and it should be 0, I know, but unless we can increase the precision in here, this error is like the best we can get. But in all purposes, like 3 decimal, especially in inches, I think it's more than enough. So that's why I left it here. But I just also wanted to show you the errors on the right. Okay, so that's about the concrete section. Let's the beam, rectangular beam section. Let's move on to T-beams. So it's basically the same layout, but in here you have B1, H1, B2, H2 instead of just B and H, right? So B1 obviously corresponds to the width of the first rectangle, and the B2 corresponds to the width of the second rectangle. The H corresponds to the first rectangle's height, and then the H2 corresponds to the second rectangle's height. So notice that this 18 means the height from this concrete layer, not the whole thing. So that should be clear. And the right obviously is the strain diagram. It's just that, and then the steel is the same thing, material is the same thing. The only thing that changed was this left input of concrete, and then you can just click calculate, and then it will calculate, and it gives you the result. And finally, the custom section. So custom section is pretty interesting. Just like the steel had many layers, right? You can put concrete as many layers, and also you can make the section trapezoidal, so not just rectangular. So in here I made like 5 concrete layers. This one, like the second layer is trapezoidal, and then the 4th layer is also trapezoidal. And then the cool thing is that you can see what happens if you move the steel downwards, right? I think I made some calculations, so hopefully it's correct, and you can decrease it, and then you will keep the 3 inches of cover respected. And then if you go here, it's kind of buggy, but if you go a little bit here, it's also kind of buggy, but who wants to put 6 steels in the middle, right? So you can just keep going like that, and then the graphs would just be adjusted. I think later on I will do like export button that you can just export this picture in AutoCAD format, so you can draw the concrete based on this, and then just click it and then save it. I've already done that, and it's just a matter of pushing the update. So that's that, and let's go on to the concrete. So we have concrete layers, like we have 5 layers currently. The maximum is 10. The bottom top means the width of the top, so it goes layer by layer, right? And the top is 24 and the bottom is 24, which means it's rectangular. So this width is 24 and that width is 24, and the height of that concrete section is 4. So the next section is like trapezoidal, right? So the top is 24 and then the bottom is 20. So I can just make this into like, let's say 15. Let's see if that happens. So it's kind of like, I can even make it like a Christmas tree Like, so let's just try that. Yeah, I can do that. Let's just make this a 0 even. So yeah, something like that. This even works. This is allowed. So you can, and then obviously you just make these adjustments on your own, and then click calculate, and then it would just show up your results and then update the strain diagram. So that's about it. And this is how you make moment calculation of reinforced concrete beam section analysis, essentially. So let's go to the about section. So in here, I try to make some sort of updates to the user. So future work, I'm going to work on concrete analysis instead of just beam, right? And then hopefully I can get on doing like structural analysis of a beam, if not just a section analysis. Just a moment, force, shear, whatever, everything like the curvature and the displacement diagrams and stuff like that. And so this is a website, a web application, but you can even install this on your home, like a laptop or desktop or mobile application even, because this is like a progressive web application. So what that means is it is a browser application, you can say, but you can also treat this as like a mobile app also. The way you do this is if you're using Chrome on your mobile, then you can just click on the option, like the 3 dotted on the top right, and then you can just click on add to home screen, then this application would just appear. But if you're using Chrome, there is I can even show you here, there is this plus button. I think I installed it already. So let's try. I had zoomed in here. So let's just try in here. So yeah, so I already installed this. There should be like a plus symbol in here, and then you can install it, and then I can just click open, right? And then this opens up as the concrete application. So this is your desktop version, but essentially if you have a mobile application, it will just show up on your home screen as a mobile application also. So that's convenient. And also if I made some updates, then you can just instantly get, click, like there's going to be like a pop-up on the top saying, okay, there's an update, would you like to do it? And then you just click okay, and then you'll, get the latest update. But if it's not updated, then you can just obviously delete that application and then just reinstall it. So that's going to work like that as well. Okay, hopefully that cleared things up. A little bit of introduction of this web app. So gostructure.com is the domain name. And take care, and I would be welcome to any feedback, suggestions, or any bugs, basically. All right, thank you. Bye-bye.